Welcome to Reliability Matters, a podcast for the electronic assembly industry. Each episode covers topics related to reliability, best practices, and environmentally responsible assembly techniques, with insights from experts across the electronic assembly industry. Now, here's your host, Mike Konrad.
Welcome to another episode of the Reliability Matters podcast. I'm Mike Konrad. I'm so glad that you're with me today. Many of us in the electronic assembly business start with the circuit board. It's the first thing we start with. We don't make the circuit board. They show up miraculously one day in our shipping and receiving department. And then we build the board up from there. As the biblical parable stated, the foolish man built his house upon the sand, while the wise man built his house upon the rock. In this case, the circuit board is the proverbial rock. My guest today is Dr. Kunal Shah, President and Chief Scientist of Lilotree, a company which provides surface finishes for the electronics assembly, for electronic assemblies, which purportedly provide optimum performance and better reliability of circuit assemblies. We'll dive into that claim in just a little bit. Dr. Shah leads advanced engineering materials development for the electronics industry. He is the inventor of ENIG Premium and nickel-less ENIG Premium, and other surface finish solutions. Previously, Dr. Shah worked as a senior research scientist at Intel Corporation and Pacific Northwest National Laboratory. At Intel, he developed polymer interlayer dielectric and passivation material that led to the design, adoption, and integration of polymer passivation materials in Intel's IC products. He has been the recipient of numerous industry awards and has authored several scientific papers and patents. Some of you may be asking, what are surface finishes? So we're going to start very basic in just a little bit. And some more of you may be asking, well, what allows a surface finish to provide optimum performance and reliability, as the prior claim suggested? My guest, Dr. Shah, will answer these and other questions. So without any further ado, Dr. Shah, welcome to Reliability Matters. I appreciate you being here.
Absolutely. Thanks for having Mike on this podcast. This is very exciting.
For me too. Let's begin with your company. I always try and find out the nature of a company name. Sometimes it's pretty obvious. You know, my company's Aqueous Technologies. We build water-based machines, so you don't have to go too far in your creative mind to figure out what it is. Yours is Lilotree, and I have, if I were to just see Lilotree, I would have absolutely no idea. So it must mean something to you. So tell me what Lilotree means.
It does. It's actually very much similar to the analogy you brought up, the aqueous solution that or aqueous technologies that you have. Lilotree, it may not be as obvious for most of the people, but in Eastern culture or one of the Indian culture, Lilotree means green, anything that is green. And basically the materials and surface finishes that we have developed and we supply to global manufacturers, all of them are eco-friendly or green chemistry. And for one of the example, the major example is the gold chemistry has been used for decades for plating, and they use mainly the cyanide based gold solution, which is very we know the environmental aspect and the health aspect of those cyanide-based chemistries, and we have completely gotten rid of that. Our chemistries are halogen-free, RoHS compliant and REACH compliant, and basically anything that can be as green as it can get. So the idea of the name is the green solutions or green chemistry. That means the Lilotree solutions, basically.
So your company is Lilotree. Your products are very Lilotree, to put that in the vernacular that you're citing. Oh, very good. The greatest thing about hosting the show, I learn new things every time I do it. So that's amazing. And sometimes I learned that I didn't know it right. So either way. Tell me a little bit more about Lilotree. We know where the meaning comes from. When were you founded? What markets do you serve, and what types of products do you offer?
Yeah, so actually, surprisingly, we've been actually in the business for almost 10 years now. Recently, past 5 to 6 years. So again, past 10 years, we've been supporting aviation, aerospace, medical electronics, consumer electronics, and semiconductor industries. That's my background. I'm a chief scientist there in the company. We've been actually supporting a lot of these industries and a lot of their products in terms of when the failures occur to their products, they come to us, and we do exhaustive investigation of what caused the failures and why these products are failing. And then we provide them guidance. We work with their vendors and suppliers and to improve the product from a ground up, from a materials level perspective. Along the way, even since we have a materials background, as you brought it up in my bio, again, I've been in this industry for more than 20 years now, and have a staunch materials expertise in this area. We've been getting a lot of surface finishes related failures. So even though the assembly will come to us, we analyze and it's like, oh, it's the intermetallics, it's the solder joint failure, it's the corrosion at the interface, or all those failures were coming so predominantly from a high reliability customers. Their batches of that product, when they identify the failure and we help them say, okay, it's the surface finish, that batch would cost them several millions to several $100 million. They have to worry about the lawsuits and the recalls and everything under the sun. And that's when, past 5 to 6 years ago, we actually realized that, hey, there has to be a better surface finish out there, which does not lead to these, gruesome failure that we are seeing. And not only it's the money, but, some of these products are used in aviation aerospace, the, planes that we fly in, or some of the aerospace research that go on. So, and some of these products actually go in some of the patient's body, being a medical electronics products. So it's beyond the money. There is a lot at stake to have a high reliability being played out in these assemblies, basically. So that's where we started out, offering, developing the surface finish products, and now basically we are one of the global suppliers of these products.
Yeah, there's always two types of startup companies. One that looks at a product and goes, well, we can do that just as well as anyone else, and they just kind of pile on, become an also-ran. And then there are those that look at either we can do it better or we can do something radically different. And those are the companies that inspire me, rather than an also-ran. So let's just, I don't want to take for granted that every listener to the show knows what we're talking about. So let's get, let's go back to elementary school a little bit, and let's just kind of build up from a similar foundation. Let's begin with the basics. What are surface finishes, and what functions do they perform?
Yeah, so as going back to really basic, everybody in this world, pretty much, if I sort of generalize everything, is using electronic product, be it a cell phone or a TV or anything, something really basic has electronic assembly built in it. And now electronic assembly is sort of a heart, or where you brought up an analogy where the house is built, the basic structure or the pyramid is built upon a printed circuit board. And now printed circuit board are manufactured in a printed circuit board manufacturing, and then it gets transferred to another manufacturing facility. Is called assembly, where different components are put on these printed circuit boards and form assembly based on the design, based on where the application is of this product. So there are different components, different chips, different capacitors and resistors, and everything sort of get assembled, and that's why it's called surface mount components gets placed onto these printed circuit boards. Now the area where it's put on is a copper pad essentially, and that is, these copper pads are at the time of the printed circuit board manufacturers actually lay out this designed circuit, and these copper pads are laid out based on the circuit, and then these copper pads will have all these surface mount components put on it. Now these are copper is typically very corrosion prone. It gets oxidized, it gets etched, leached out with the different environmental condition. Even regular environmental condition, it gets oxidized within few minutes or so.
Anyone who's visited the Statue of Liberty knows that, right?
Yes, right. It's turned into green, which was not the case in general. So yeah, either oxidation products turn into green, or some sort of a red or rust of some sort if it is iron. But in the case of copper, you will have an oxidized surface. And why oxidized surface is bad? Because now if you try to put a solder to put a component on it, it will not wet and it will not form a solder joint. which is a major failure mechanism. So you want to ensure that your copper pad is absolutely pristine at the time of when you are doing assembly. And that's why you put different sort of coatings, and these coatings on copper pad is called surface finish. Basically, it's finishing the copper pad to ensure that the copper pad underneath is protected, and it does its job at the time of assembly when these surface mount components are placed on these copper pads. Now, I'll actually jump one more, just because right now we are talking in an introductory fashion, but I want to sort of also identify and distinguish what a typical surface finish does and what Lilotree's product does and why we are different. So, as Mike pointed out, and our company's logo or slogan is optimum performance and better reliability. So most of the surface finishes in the market are their goal is to, all right, let's just protect copper so it's not oxidized, and at the time of a surface mount component, it gets the 100% copper and it's all completely protected. That's how the surface finish was designed. However, what is the concern in terms of assembly level? Assembly level concern is they don't care about what surface finish is applied as long as you have a good, strong assembly where the component are attaching to these copper pads strongly. What is attaching that is a solder joint, right? Surface finish doesn't do, or has not been, from any supplier that you use surface finish from, doesn't do any job of forming the solder joint. Their goal is to have a pristine copper surface, then the solder joint will be formed by the solder itself, or the solder material or solder chemistry.
Right. The moment the paste is put down and it reflows, it's done its job. That's it.
It's done its job.
Right.
Absolutely. That's where it ends. So Lilotree actually has taken one step forward, where the chemistry of the surface finish participates at the time of soldering process or a reflow process, and actually forms a very robust solder joint. And what Lilotree surface finish does, it actually regulates the chemistry at that interface when the solder joints are forming a very, very robust solder joint. And that is why the surface finish is participating in forming a robust solder joint, which was never the case with a traditional surface finish that are out there in the market.
So it sounds like unlike a traditional surface finish, which ends its responsibility the moment things heat up. Is this acting in a similar way to flux? The flux's job is to provide, reduce oxidation and provide better wetting and things like that. And surface finishes prevent oxidation. And in this case, you're suggesting that it also improves wetting. So it kind of sounds like it's a combination of surface finish and flux in many ways.
No. So I think, Mike, you brought up a good point, that flux actually does help at the time of if there are any chemical reaction that is happening, that is oxidation of any sort, that is affecting the subsequent soldering process. This actually surface finish is actually, so our surface finish basically gets diffused into the copper surface almost 400 to 500 nanometer into the copper surface. So what it does is, when you have a reflow process where basically dissimilar material are coming together and forming a solder. So basically in the case of tin, and for example in the tin and copper, it forms a tin copper intermetallics. In a typical solder joint, if Lilotree's products are not used, and a typical how other products are sold, so basically multiple reflow cycle happens. So if somebody knows about reflow cycle, for example, a lead-free reflow profile can go to as high as 255 to 265 degrees Celsius, and then comes back again, and then there's another cycle, and depending on the how complexity of the board. As it goes through the reflow cycle, the copper actually diffuses into tin, and that diffusion and basically then they start coexisting. That coexisting phase is called intermetallics, means one metal from copper or a surface on the PCB side, and then a metal from from a solder come together and start to coexist. It's called solder joint or intermetallics, right? For typical electronics industry, what is the weak link in terms of the assembly? What is the phase, or what is the area where most failure happen? Is the solder joint. Is where the joint is occurring, where the intermetallics are formed, because it's a non-similar metal. They may not be sitting well together. Instead of having a uniform homologous material, you have a dissimilar metal working together, so they may not like each other as much, and putting it in a much more comical sense. But the idea is dissimilar metal, this phase is the softest, and whenever you have a drop, like if you drop a cell phone, or if there is this is a very simple analogy, but in a much high reliability aviation, aerospace, medical electronics, there are much more stressful scenarios where these assemblies actually tend to fall or fail at these intermetallics. And why? It's because this copper keeps on diffusing into tin and forms a very thick intermetallics, and these thick intermetallics seem to form these phases which are very, very brittle. So what our surface finish has done, or what our chemistries have done, is actually this diffuses into copper. So at the time of reflow, it actually prevents too much diffusion into tin. So intermetallics formation, the thickness is significantly reduced, and that makes the intermetallics much more. So instead of having a larger area of intermetallics, you have a very thin and distinct area of intermetallic. That makes overall reliability much higher.
Sure.
And instead of our traditional ones.
Yeah, and we'll get into the tricks that the tricks in my world, the tricks, the magic that you invented or realized that makes your product work the way it does work. But I want to stay basic for a little bit, tiny bit longer. What are the most common surface finishes that are in use today?
Yeah, so I think most of the industries use. So if I go back in history, early 2000 or even previously, there used to be or there's still a surface finish called Hassel, hot air solder surface leveling, basically. That used to be a lead based Hassel, which is basically even the surface finish is also made up of solder material. It's tin based surface finish, and it used to have a lead also in it. And now when the incoming solder comes in, it's looking at the same material instead of a dissimilar material. Solder joint used to be very, very strong because it's attaching this like and like instead of dislike, dissimilar materials, basically. It used to be very popular. However, in early 2008 is when sort of a switch happened, where things or industry started going into lead-free realm of things, and that's when the lead-free Hassel did not work as well. And there were other issues because of the surface planarity was not very good. There was very high surface roughness with Hassel, so there were some of these small BGAs and small form factors were not conducive with these older technology. I think along the ways, ENIGs, electroless nickel immersion gold, early 2000 started becoming popular, and actually even till date, it's one of the most prevalent surface finish, especially in a high reliability sense. One of the benefits is it's got the gold layer on the the final gold layer, which actually provides you and offers you more than 12 months of shelf life, which is what is very critical. You need to be looking for a gold-based surface finish with the geopolitical and with the COVID and all the situation where your one factory is in one country of the world and another assembly happens in another country of the world, and supply chain logistics issues and everything. So anyways, coming back to the idea is ENIG, electroless nickel immersion gold, is one of the most prevalent one, which is, I would say, if you look at the number, it's the highest revenue surface finish in the world. There is another one I would put is OSP, organic. It's organic, and it's a polymer, basically, that it's put. Organic surface preservative is what it's called. So basically they put a polymer sort of a layer on top of a copper surface. It's basically very cheap, cost effective. It's, I think, based on a statistic, it's actually used the most. So basically, if there are certain million of square meter of printed circuit boards are made, the highest surface finish used, it's not the highest revenue because it's very cheap. So it actually, ENIG is where it's made by most of the manufacturers, but it's the highest used surface finish is because low reliability, consumer electronics, things of that sort, they use OSP. It has its own cons, along with some of the pros, which is cheap. But there are several cons that usually high reliability product you don't see OSP. It's mainly used in Asia more than as much in America. America is mainly electroless nickel immersion gold is what is most prevalent.
Right, but for consumer class one stuff, where price is everything, and the economy of scale drives down the costs, or the desire to drive down the costs, that makes sense.
Absolutely.
You talk about ENIG and its longer shelf life, 12-month shelf life. I can't help but think that is more desired now than before, because your boards might be on a ship for 6 months waiting to be unloaded, and then once they arrive, they might be another 6 months before you get the components in to mount to the board. So 12 months seems like a long time, but it probably isn't quite long enough these days.
No, absolutely. It is very, very much likely that people had not thought of these issues like 3 years ago, 2.5 years ago, and now they are becoming real, where it's not only the printed circuit board, the copper clad has a shortage, so it takes 2-3 months. By the time printed circuit boards are manufactured, then it takes 6 months to get to another place. And then the components are making you wait. So by the time you realize, it's already 12 months and your surface finish is already sort of at the point of compromising.
Right.
Just to give you an idea, in comparison, OSP has a shelf life less than 6 months. So you can understand how much of the trouble that you have if you use some of these products versus something that you have to use which has a very long shelf life. And I think that is one of the things people have started considering very seriously in terms of selecting the right surface finish for your products, which is very, very important.
Yeah, we'll dive into more of the attributes, but since we're on the subject of shelf life, does your product, you call it ENIG Premium and Ni-Less ENIG Premium, does that technology offer any different shelf life than a traditional ENIG material would?
It's a very similar, because we are so our products are also using gold surface finish as a final finish. Yeah. So whatever gold offers, so it's very similar to ENIG or
Gold is gold. It doesn't matter the thickness. We'll get into the thickness of your gold later, but the fact that it's gold, you're playing by the gold rules, the golden rule, so to speak. Yes. So Lilotree was awarded a Small Business Innovation Research, or SBIR, grant from the National Science Foundation, which, congratulations, very impressive, to develop ENIG Premium, which was designed to resolve field failures where black pads and brittle failures at solder joints were found to be factors contributing to the malfunctioning of devices, to reliability issues. Tell me more about those failure mechanisms and how surface finishes contribute to those failures, and more importantly, how surface finishes can help resolve those failures, help mitigate them.
So I think traditional, Mike, as we've been talking about ENIG acronym for electroless nickel immersion gold. So basically there are two layers. Once you put electroless nickel phosphorus layer, and then you followed by putting an immersion gold on top of it. The traditionally how ENIG, and I will not go too much into chemistry lesson here, but sort of very briefly that typically immersion gold is a galvanic displacement. So what happens is it actually takes away nickel and then puts one gold atom in that location. Now, if you keep on doing that, and if there are certain grain boundaries in this surface, which is obvious, there are going to be grain boundaries on this nickel surface. These boundaries, there is quite a lot of exchange of nickel with gold. So basically, there is a deep crevices being created where gold keeps on displacing nickel, and these deep crevices where this displacement of gold is or displacement of nickel is happening due to gold. That is actually a black pad. Now, what is black pad is that localized region becomes phosphorus rich. So basically, the traditional layer is nickel phosphorus, where roughly 90% nickel, 10% phosphorus. Now, just because the gold has displaced nickel in that area and quite a lot of displacement has occurred, that area becomes phosphorus rich. Instead of 10%, now it's become 15%, 20% localized. Instead of a uniform material, has only 10%. Now that phosphorus rich area, it's appearing black, and that's why it's called black pad in a scanning electron microscope. That's where the name has come up, because whenever you put it in an electron microscope, it appears as a mud crack and it appears black, and that's why it's called black pad. Now, what is a failure mechanism is whenever you have these issues where when it goes to an assembly, these pockets of area will not wet well with the solder. So the phosphorus rich area will not wet well with solder. So you have pockets of area. So if there are multiple pockets, the overall entire pad is non-wettable. That is a sort of the first level of failure that assembly folks will realize. But assembly folks may not even realize, and they will still wet, but there are still pockets of area where the wetting has not occurred. So you have a area where there is a wetting, then there are pockets where there is no wetting. So you already have sort of a voids and not a complete entire solder joint, right? So it's already brittle in the first place, the nickel tin intermetallics, and now you have voids of pockets where the intermetallics has not formed. So it's already compromised. So any stressful condition, that will have a brittle failure at that intermetallics. So that actually makes things the worse. So the idea is our technology, we call it as ENIG Premium, where we put sort of a barrier layer between nickel and gold, and then incoming gold it's actually not forming these pockets of non-wetting high phosphorus area. And then when the intermetallics are formed, there is a continuous layer of intermetallics instead of pockets of voids where intermetallics are not formed. And that's why it actually dramatically improves and increases the reliability.
Yeah, interesting. Back in the early days of LED lighting production, silver was used as a backing material, and then it was discovered the hard way that in regions of the world where there's more sulfur in the air. We ended up with like tin whiskers or the failures, major failures, and then they realized that not the greatest material. Is that also maybe not that specific sulfur-induced issue, but is that also a concern with shelf life and surface finishes where geographically the boards are stored? Are there places in the world where your 12-month shelf life might be 6 months based upon environmental issues?
Yeah, no. So Mike, yes, it is something that you have to be very much aware of, because certain area is more moisture prone. So, for example, the ENIG 4552, or rather the IPC 4552, is the ENIG standard specification that's out there, and basically it refers that you should have a 3 to 6 micron of nickel and only nowadays 35 nanometer, which is only 1.5 micro inches of gold. Right now, gold is very, very porous, and if you have a moisture in the air, I mean, you could actually start seeing the gold being compromised, and you will have a compromised surfaces. So the idea is, you actually in those areas, you want to tend to tell your PCB manufacturer that I want much thicker gold, close to 70, 80 nanometer, which is almost 2 to 3, maybe 4 or 5 micro inches, close to 100 nanometer, compared to in other areas where moisture is not an issue, it's properly stored, and you don't have to worry about these pads getting compromised because the thickness is very little. And we'll talk about thickness in a little while, but it is a very critical aspect of gold and how it's being controlled and whatnot.
Right, but it sounds like, and we will get into the details of the thickness in a bit, as you point out, but just to kind of put a bow on this in context with what we're talking about, it sounds like if all you need is 1.5 nanometers.
Actually, 1.5 micro inches.
I'm sorry, yeah.
35 nanometers.
Yeah, so all you need is 1.5, but other methods use a much thicker thickness of gold for other purposes, because because of the porosity, the moisture breakdown, moisture intrusion, things like that. So, last I checked, gold isn't cheap. Even very thin layers of gold, maybe each board doesn't have enough gold to melt down and make a wedding ring. But then again, we're not making one board; we're making hundreds of thousands, if not millions of boards. Right?
Absolutely.
So
that is something. Something is very, very cautious or sort of cognizant about any designer or any OE or even assembly houses have to understand that, hey, at the end of the day, I'm using precious metal, right? And if I'm using 10% more of precious metal, my boards will be costing more. I've actually we work with a lot of PCB manufacturers, and and some of the price sheet, and depending on the surface finish, the board can cost as much as 100% more compared to 100% less. So the selection of surface finish is very critical, and especially the thickness of gold. One of the distinguishing feature of our product is, typically in the immersion gold world, the way it is it's sort of a sludge hammer. What I mean by that is there is no control. You put it in a bath, and then it gets plated, and you don't have a control of a thickness. So you will have a much larger variation in the thickness. In certain area, you will have a 2 micro inches or 1.5 to 2 micro inches. In other areas, you have 5 micro inches. So your distribution is such large, you don't have a control. One of the idea, or one of the product that the feature of our product is actually you can control the gold thickness by half a micro inch precision. So if you decide that, okay, I just need 1.5 micro inches. So you will actually, any pad or any area that you have 18 by 24 inch large panel, any pad you pick, your thickness will be between 1.5 micro inch and 2 micro inches. Instead of a 1.5 to 5 micro inches spectrum, you'll have only 1.5 to 2 micro inches. And that actually saves more than 40-50% of the gold consumption saving. Because I think one thing is to protect from the environment, but if there is not required, you do not need to put, if the requirement, and if your environmental issues are not there, if you store it well, if your requirement is only 1.5, you should not be putting 5 micro inches. So that's why the idea is to sort of keep it within 1.5 to 2 to make sure that you are within that range instead of putting 3, 4, 5 micro inches. So that's the saving.
To someone who's a layman like myself, not well versed in surface finishes to the level you and your team are, it's kind of conventional wisdom that the more of something valuable, the better, right? Certainly, if you're wearing jewelry, the higher the carat weight, or the for diamonds, or the ounces of gold, the better. But in this case, more of something is not necessarily better. It obviously can be worse. It's the right amount. To a point where if you put too much of gold, it actually can create a reliability issue with something called gold embrittlement, where you want to stay away. Because this gold is going to get dissolved. It's not that you're keeping it. It's going to get dissolved in solder. So you won't even see it once the assembly is formed. Right. It's just to protect, like a final layer that gets dissolved at the time of reflow. So it gets dissolved in the solder. You won't even see it. But if you have too much, it actually forms a brittle pockets within the solder, and you will have a failure on those locations. So right.
You want to control as little as possible.
Yeah, and that must be a result of the blending of the metals, because gold itself is a soft material, right?
Correct.
I don't consider gold brittle. I consider gold soft and
right.
pliable, to a certain degree, but it's interesting to think of it as brittle. So electronics today, as you well know, Kunal, are ubiquitous. They are everywhere. They're surrounding us. And IPC categorizes for various levels of expected reliability. For example, they have class 1 products, which are electronic flea collars and things that we don't die if they fail. We just buy another one. Class 2, office equipment, things like that. Class 3, military, medical, even a space categorization. Additionally, there's a greater awareness of harsh environments these days, probably because of IoT and electrification of cars. We're putting more and more electronics out into the cool, cold, moist world than we did before. And a lot of these devices that are going out to harsh environments are class 1 devices. They're consumer gadgets, wearables and things like that. So they're not necessarily built to class 3 standards. But then again, even the cheapest part needs to last, right? Otherwise, they'll never sell a second one. So how does one go about selecting the most appropriate surface finish for their application, whether it's harsh environment, whether it's class 1, whether it's space? How much does, I consider a surface finish's job, as we talked about earlier, to protect the copper up until the point of reflow. But it sounds like the incorrect selection of surface finish can also result after reflow in some issues. So it has a responsibility even after reflow. So how does one go about selecting the appropriate surface finish for the appropriate application?
So Mike, as you brought it up, I think some of the things we already discussed in the past, but like for example, class one, class two, class three, sort of as you go into the ladder of higher reliability or higher sort of reliability is aftermath, but criticality of the application. The more the critical application, the sort of a reliability requirements or reliability expectations increases, because you cannot have a device or assembly failing in somebody's heart or a body, or a multi-million dollar investment in the space, where the failure occurred and the entire project come to a halt. So the expectation of reliability increases multifold, and those are the places where I believe the first thing somebody, or one of the critical aspects somebody has to be looking for in this application is the solder joint reliability, because that's the end. That's sort of surface finish goal is to make sure the traditional surface finish or Lilotree surface finish, irrespective. So the surface finish goal is to make sure that surface is absolutely pristine first, and then it forms a very continuous, strong solder joint. Now, traditional surface finish do not participate in for forming a solder joint. Lilotree surface finish does, but at the end of the day, it has to have a continuous, strong solder joint, and that is what is the critical aspect. So that is one thing, and a selection criteria from a assembly perspective or an OEM has to be looking for, depending on the criticality, was it a class 3, class 2, class 1. But then also they have to understand that there is a second aspect, is the shelf life that we talked about. When it's going to be PCB are going to be manufactured, where it's going to be assembled, what's the time frame, what is the supply chain logistic, are the components available. So the shelf life is also second and most important thing, especially now this day and age. There are so many things going on with the war and with the with the supply chain logistic issue, with the COVID and whatnot. And third thing I would also put is the precious metal, the use of precious metal. I think we talked about it, that one of the use is gold. How much thickness do you have a control of the gold? What are the environment is going to be subjected to? Is if it is a harsh environment, you may want to put it slightly thicker gold where you have a control, but also you don't want to put extra gold because it may eventually turn into a solder joint failure. So having understanding of how much thickness of gold I need to be putting, what are the my supply chain logistic that is telling me. One more thing which we have not addressed is, traditionally past a decade or so, there is, because of the issues with ENIG, there is palladium has been sort of included in the mix, and the product is called ENIPIG, which is electroless nickel electroless palladium immersion gold. And nowadays, with the nickel being frowned upon in certain applications, which we are going to be talking next, there are products called EPIG, which is electroless palladium immersion gold, or similar products, where they've included palladium in the mix. So now when you are looking at these precious metal being included, their thicknesses and what type of precious metals are included is also something somebody has to be wary upon, and also be very cognizant about. The idea is, just to give you an example, palladium actually costs more than 1.5 times the cost of gold. Then a lot of people don't even know that, oh yeah, I want palladium. People say it's more reliable, let me just throw in palladium in the mix, but it's even more, 1.5 times more than gold. And to make things worse, the largest supplier of palladium in the world is Russia and Ukraine. So because of this is going on, the cost of palladium last 2 weeks has shot up almost more than 10%. Right. So it's actually getting hammered in terms of the cost. So
well, and Ukraine's not going to be able to, they're distracted with defending themselves, and Russia, there's sanctions, so there goes the palladium market, right?
Yeah, and similarly, the folks in battery world are crying over nickel. People are not even talking about. I mean, I've actually started seeing article, because that is the industry we are in, that the cost of palladium and and affecting the electronic industries and whatnot. And even there are other industries where palladium is used, that is solar industries and whatnot, and they're starting to see the pain of palladium pricing and whatnot. So yeah.
It's going to make the cost of gasoline look like a bargain by the time they're done with
Yes, absolutely.
Let's keep moving because I really want to get through these questions. In most cases, when a new product comes out that solves problems, it's priced at a premium.
Yeah.
On one hand. On the other hand, when someone says the most expensive component used in your product is being used at a fraction of the volume as traditional products, then I think, oh, well, then it should be a whole lot cheaper. So I'm sure there's a little bit of calculation that goes both ways, but without getting into the details of your pricing, this type of technology, is one of the other attributes besides reliability that it saves on cost, or does the cost savings come from the reliability enhancements?
So Mike, it's very interesting. So of course there is a reliability aspect, which is the feature of our products. But the second thing is the cost of the solutions when we ship it out to PCB manufacturers or IC manufacturers, is plating the products with our solution identical to the traditional solutions out there. The cost benefit that that most of our manufacturers realize is because, I give you an example, that they end up using less gold. So if they look at their usage of gold traditionally previously versus they started using gold, have gone down more than 40%. So the usage of gold, so when they see every month or every year when they use Lilotree's product versus when they were using a traditional product, their cost of gold or amount of money that they had to spend for gold solution has dropped more than 40%. So that is how they realize the benefit. They have to use it less. They have to sort of buy it less. They have to replenish less, and so the usage has gone down. Or because as I said, the controlled gold thickness is making them use less gold, and that is the added cost benefit that they realize over a period of time.
Right.
Yeah.
So in 1857, we're going to go back in time in our time machine, all the way back to 1857. Novelist Anthony Trollope wrote or coined the phrase, or at least popularized the phrase, better the devil you know than the devil you don't know. And
right.
Frequently our industry is hesitant to adopt new practices. The military is almost superstitious to adopt new practices.
Yeah.
I mean, they're still using lead and through-hole technology, right?
Right.
They're basically a time machine. So in aerospace markets, probably fairly similar. How has the introduction of a new surface material been received in terms of battling against just the legacy mentality?
No, frankly speaking, we're not going to, sort of say, oh yeah, it's, we've been received with the open arms. Again, there has been a tremendous amount of support in the industry just because what type of problems we are solving. But in terms of a business or in terms of adoption, there has been quite a lot of apprehensions. There has to be some caution, and beyond that, as you brought it up, a lot of time most of the PCB manufacturer in US have customers in military or in customers in in some of the legacy products where they have certain products already on their spec sheet. So what it means that, okay, yeah, even though it has a problem, even though there is a better product out there, it's already part of our design. This is what we want. So a lot of people, say, oh, we cannot change even though there is a better product out there because we need to make this customer happy, and they cannot, because if you change one product in the entire stack, they have to do all the qualification testing or approval process again, and that takes forever. And these companies, which is the aerospace industry or the defense industry, sort of always, all right, let's just keep running what's been running instead of changing anything. So there has been quite a lot of apprehension in terms of adopting a new product. But I think we're going to talk about some of the next generation product where you are required to change because the traditional product do not work, and that's where we sort of started making a mark, because then it's out of necessity instead of it's good to have, right? It's better to have, and that's where we started making a mark in terms of a next generation technology that we brought up.
Sure, no, that makes sense. In doing some research on your company, I read that your company talks, and I think I saw some YouTube videos. It talks about improved signal integrity on 5G products. Of course, 5G is a big buzzword right now. I'm even starting to hear a lot of some talk on 6G, whether that's real or not. I'm sure it is, but I'm not sure how accurate it is at this stage of the game. But anyway, 5G is basically a buzzword right now. Tell me what that means in terms of improved signal integrity with 5G and the reasons that signal integrity can be an issue with 5G. I never hear anyone saying, this is a great product for 3G, as 3G is being turned off around the country. Why is 5G more susceptible to signal integrity issues?
Yeah. So if I provide a little bit of background for all the listener, we've been using in the past, as you brought it up, the 2G and then the 3G and then the 4G. What does that mean is basically is the frequency at which these assemblies or these electronic assemblies run at. So when you talk about 2G, 3G, 4G, they were running around almost 2 to 4 gigahertz. That was the frequency that they were running on. Now, as you go into 5G, the frequency is increased. The 5G spectrum anywhere from 3, 4 gigahertz, 5 gigahertz, all the way to 25, 35 gigahertz. So that is into millimeter wave. So all these assemblies are actually going into that spectrum, almost 10 times more the frequency what 2G, 3G was running or 4G was running into 5G, 6G spectrum. So it's going all the way up to 35 gigahertz. Now, as you increase the frequency of the assembly, the current that passes through the circuit, like traditional, as we talked about earlier, the traditional surface finish has been ENIG, electroless nickel immersion gold. Now, what happens that you have copper surface pad and then you have ENIG, so the nickel layer and then the gold layer. The nickel layer is actually 1/4 to 1/5 the conductivity compared to copper. Right. And second is it's electromagnetic. So there is electromagnetism interference also comes in. So as the frequency increases, the electrons passes through this nickel layer where it's a bottleneck. Instead of passing through copper, there is a skin depth. Not getting too much into the details, but the idea is when the current passes through nickel, it's a bottleneck because the conductivity is much lower than the copper. And also there is electromagnetic interference. So there is quite a lot of signal loss. Instead of it's performing to its fullest potential, it actually starts compromising its performance because the current is not passing as quickly as it should be. And that is why it becomes necessity to use or not use nickel, even though it's the most prevalent technology, ENIG, because it's creating quite a lot of loss in your assembly. So it would not perform optimally that it should be.
Yeah, that makes sense. There's also talk about how this type of product can benefit the auto industry. What is unique? I know, there's a harsh environment element, obviously, to the auto industry, but are there any other unique characteristics that make this selection of surface finishes even more important for that auto industry over other industries?
Right, because we talked about 5G and 6G, which going from 2.5, 3 gigahertz all the way to 25, 35 gigahertz. But the automotive electronic assemblies actually run at 75 gigahertz, which is way beyond 25, 35 gigahertz we talked about with 5G and 6G. So that 75 gigahertz, it actually becomes even paramount to be not using any surface finish, which is actually compromising your electric signal integration your signal loss, instead of having some technology which is actually not adding any signal loss beyond copper does. So it actually becomes more critical for automotive industry to be using a next generation surface finish than the traditional that has been used in the market.
Yeah, I'm in the, as you probably know, I'm in the contamination removal business. And we always talk about when frequencies get that high, not only do your boards have to be clean, your thoughts have to be clean, because it doesn't take much to get frequency distortion and things like that. Right. I'm going to throw a couple of graphs on the screen here.
Yeah, right. And
there. to my audience that's listening to this in their car on their headphones off Apple podcasts or Google Podcasts or Spotify or Amazon Music or wherever, I apologize you're not able to see this, but this is an encouragement. When you get back to your office or get home, go and search the YouTube version of Reliability Matters, and You won't be experiencing FOMO, because you're not seeing the graph here. But I'm showing two graphs on the screen. One represents a traditional ENIG material, and one represents a nickel-less ENIG premium material. So, Kunal, tell me what I'm seeing here and what the differences are between these two graphs.
So these graphs, basically the x-axis is the frequency. So frequency, as I explained, that at 2G, 3G, it runs around sort of a close around 2 to 3, 4 gigahertz. That is almost the left-hand side. And then as x-axis are increasing, it's the increasing the frequency. So the first plot on the left is running until 50 gigahertz. So you can see that, and then the y-axis is the loss, which is the insertion loss or a signal integrity loss or signal loss, you can say. So basically, you can see the red curve is bare copper, meaning every PCB will encounter that much loss because it's bare copper. Basically, the substrate will always be bare copper, at least so far we know, until somebody comes up with a completely different substrate. But bare, and of course, the copper has one of the highest conductivity. Of course, there are some other materials out there, but there are a lot of other reliability aspect of copper as well. So our industry has adopted copper. So you'll always have a signal integrity loss that is associated with bare copper. Your assembly and your design should be such that there should not be insertion loss beyond bare copper. You have to encounter loss that is associated with bare copper, but not beyond that. Now, if you put ENIG on top of bare copper, which is what surface finish does, which prevalent surface finish, electroless nickel immersion gold, look at what happens. That is the blue curve. As you go into 1 gigahertz, 2 gigahertz, 5, 10, all the way to 50, the insertion loss keeps on increasing, meaning you are adding more and more loss just because you have a presence of nickel in your surface finish. So that is how in the plot on the right, it's actually plotted all the way to beyond 100 gigahertz. So the idea is the nickel-less ENIG premium, that is a product that we offer, Lilotree offers for next generation PCB technologies for high frequency purposes. It's actually hugging bare copper all the way through. Even you can see some of the around 100 giga, it starts to sort of separate it out. It's not actually really separating it out. The tester, this is the equipment tester's capability was around 80-90 gigahertz, and then after 100 gigahertz it starts to wiggle it out. So it's not real effect. The idea is it's hugging bare copper all the way through, even beyond 100 gigahertz, is basically providing the best possible performance you can get in terms of a signal integrity. Meaning surface finish should not be the one which would add to the signal integrity loss. It should be only the amount of loss that you incur with bare copper and not beyond that. And that's why it's called non-lossy surface finish. Everything else is called lossy surface finish.
Yeah, the difference for those who aren't seeing this graph, the difference on the first graph using traditional ENIG is as the frequency increases, the red line and the blue line separate. It's almost an upside down V. It is a very linear separation relative to frequency. On the nickel-less material, there's pretty much parity. It's basically one line directly over another line with almost, very, very, very little separation toward extremely high frequencies. Is that a good explanation for the visually impaired?
Absolutely accurate. Yep.
Yeah. So your company states that nickel-free options such as and you talked about this earlier, EPAG, and DIG. I'm not sure what DIG is.
It's direct immersion gold.
Okay. Are associated with reliability issues. And you hit on some of those before, palladium and with costs. Anyway, what are those issues and what's the primary cause of those issues, unique to those other materials?
Yeah, so with the palladium-based technology, it's been reported there have been brittle solder joint failures reported with the palladium-based technology. So it's not necessarily providing the robust solder joint. With DIG, as I brought it up, it's direct immersion gold, where instead of putting, so palladium, nickel are some sort of a barrier layer. So basically it's preventing copper diffusion to the gold. So we use a proprietary barrier layer, which is organic in nature, and it creates a treatment to the copper to provide that barrier. So that's why it's cost effective. We are not using any palladium or any nickel in this particular technology. But direct immersion gold is actually, it's depositing very thick gold, because basically hoping that even copper diffusion occurs, it remains here and it's not coming to the surface. So surface is still good and it's not compromised. With the direct immersion gold, it's exactly the discussion we've had. Is if you have too much gold and it goes into the solder, for example, in the BGA, it's only 0.5 millimeter BGA, and you have half a micron or 200 300 nanometer of gold diffusing into solder, the solder will be brittle because of the gold embrittlement issues. So you don't want to be dumping so much gold and hoping the good performance will come. There are reliability issues with that as well.
Sure. With this considerably thinner layer of gold that premium provides, does that, with less gold infusing into the solder, does that affect at all in a positive or negative way the pull strength or shear strength of the actual intermetallic bond?
No, I mean at certain point, I mean like anything between 2 micro inches to 4 micro inches would not lead. The gold will not affect positively or negatively in terms of the solder joint strength. It will just get diffused in the solder. And basically there are numbers out there where it has to have a certain amount of thickness. A certain amount of gold has to be diffused into solder, and that concentration of gold present in the solder would lead to gold embrittlement. But anything between 2 to 4 micro inches is too little to cause any negative or adverse effect. Once it gets dissolved in the solder.
Mm-hmm.
But the solder reliability actually brought up, as we talked about, is how our barrier layer actually gets diffused into copper and preventing that copper diffusion and forming very thin intermetallics, and that is how the improvement comes about.
Right.
Yeah.
So our Lilotree, you developed this unique formulation using less gold and other attributes. How unique are those attributes? Are the other surface finish companies sitting around going, I'm watching you and I'm going to wait and see how you do, and then we're just going to all jump on the bandwagon? Or are they still clinging to the technology that they've had for all these years? Or what's your take on all that?
Very interesting. So I think it's the first option you brought up. I hope that they don't cling on and we still have our edge last for long time. We do have several patents in our technology, and in terms of comparison, we are humbly speaking way better in terms of the performance you saw in insertion loss, but even in terms of reliability. I mean, I always say from a perspective is, we believe that we saw that surface finish could also participate in the improvement of reliability, which other surface finishes or traditional legacy companies have not seen it. Our goal is to form better reliability in terms of solder joint assembly or solder joint strength, and we have our proprietary technologies are protected by several patents across the world. So we hope we continue that edge for several years to come.
Yeah, excellent. Yeah, I know when Elon Musk at Tesla, was building his company, he famously offered to give away many of his patents, and people asked him, why would you invest all this research and considerable amount of money and then just give your patents away to your competitors? And his answer was surprising. It was, he didn't want to be the only one doing it, because he will do more business if everyone else jumps into the electric world, right? And it becomes mainstream rather than fringe technology. And I think that's probably a big picture, pretty wise move, or certainly one can say crazy move, but we'll see. Is it crazy like a fox or just crazy? Time will tell.
So Mike, the way we think is, by we entering in the market, it made other people consider us from a adoption from a OEM and PCB manufacturer, but at least also it actually made other surface finish companies to also join the party in terms of thinking about how they can improve the reliability, instead of, hey, let's just not worry about, it's been going on for 20-30 years, let's just keep making money. and if customers liking it, and if everybody, it's just let's put certain thing under the rug and not worry. It is sort of a scenario. Now they have to pull their straps up and improve their products. At least that is how we think it. One analogy, and of course we are nowhere close, and we are not saying we are that, but at least we see one thing is there used to be a legacy internal combustion engine, and somebody came up with the electric car, and every company is now joining electric car, especially with the gas pricing and everything. And again, there is nowhere there is a analogy or comparison, but at least the idea is the world is it's becoming better when you have a newer technology, and hoping we live in an environmental free, a good clean environment with toxic free world in terms of a chemical and in terms of reliability, a better reliability technologies.
No, that makes sense. In many ways, it's like how Apple made Microsoft products better. Just by raising the bar, and the Japanese auto manufacturers in the 70s ended up making American car manufacturers better because we had to compete, right? So someone has to raise the bar, and then other people will sit back, watch, see if you're crazy or wise, and then jump on and pile on. One of the last questions, and then I'll ask you one parting question. The board fabrication process. You're preaching, I use that in a good word, you're selling your product, not really to board fabrications. I mean, you're selling people on your product. Your target audience is not the board fabricator, even though that is physically your customer, right? Yeah. But the people that you're trying to convince that this is a better technology are, ironically, not the people who are going to pay you money. They're the people who are going to specify your product into this, third-party contract manufacturer. So there's a little bit of a separation between the person who pays you and the person who selects you, which adds a complicating factor. So if someone decided that they like what they hear and they're going to specify ENIG Premium or Ni-Less ENIG Premium, is it pretty assured that any contract manufacturer they go to on any continent will know, oh yeah, we know what that is? Or will some of them turn around and say, we've never heard of that before? Where are you in that penetration of that market?
No, Mike, absolutely. You have absolutely accurately explained the market scenario with our industry. Is basically our real customer are the OEM, even though they are not paying for it. The only thing they are doing is specifying, and the more they specify, sort of larger the OEM, and the more they specify, you will see it's being adopted. Our product is being adopted by PCB manufacturer. For that matter, actually, we work with so many Asian PCB manufacturer along with the American ones, but in all of the PCB manufacturers, like, hey, we are working with a large OEM. Let's do evaluation together, and once they approve it, your product is in our floor or in our manufacturing facility. So this is how it's been going on past couple of years. In terms of the adoption, in terms of knowing about the product, of course, 2 years ago, a lot of them is like, oh, what's that? Let me find out. Go, what's that unique name? And then they do Lilotree.com. Now it's changed. Actually, past a year or so, we've got a lot of exposure from PCB manufacturers in United States. It's always like that, but in Asia as well. We've actually partnered with one of the largest distributor company in Japan, who has been helping us spread the word and getting it adoption and getting it distributed across the entire world, because they're one of the largest in the world in terms of chemical distribution. So they actually help us distribute in Europe, in Asia, in America as well. So a lot of them have adopted it, but a lot of them have actually heard of us. They're in the different phases or different stages of evaluation, maybe early stage to a stage where they have completely adopted, in the sense that they've completely finished the evaluation, they love the product and are waiting for it to be adopted. So there is basically every spectrum of which you will find. But at least I would say that most of them have at least heard of us, which we call it as it's in a different perspective. It's a success because we are not a legacy. We are starting out from scratch. So at least that we call it as a success matrix compared to the legacy ones where, yeah.
Yeah, that's always a challenge at first, getting people to just know who you are. And then the second challenge, of course, is to be selected. So what as we finish up, what's the future for Lilotree? You've already solved one problem. What's next on your checklist of problems to solve and how to make the world a better place?
At least the surface finish industry is a very very large and a complex industry. Even though we may have actually made it in this conversation to sound very straightforward. Oh, these are the chemical and you just sell it. But nowadays with the complexity of printed circuit board and the next generation, I think some of the feature size and the line and the feature space are going into like 2 or 3 micron, even smaller than those. So to figure out with surface finish with their demands and type of surface finish, the type of laminates that are being used and being compatible with all of those, and the surface finish itself, we have few other surface finishes also in the pipeline in terms of development. We have sort of, I'm saying some of the things out loud, where we have our own Lilotree's own OSP is coming up, which is way more cost effective, and there is no gold layer, and so we may have addressed some of the traditional OSP's problem with our own OSP brand or version to it. So we do have several products in pipeline. So our goal is to make sure that we offer this surface finish and continue to provide reliability along the way. And in that process, they end up using a green chemical with a lower cost. So that's sort of summarizing what we want to do in the future.
Well, Dr. Kunal Shah, thank you so much for being my guest today and for explaining to me and my audience how there are solutions to reliability issues that can be solved by the appropriate selection of surface finishes. I appreciate what you're doing. I appreciate the fact that your product and anyone's products that can make the world more reliable are out there. That makes me feel a little bit better as I'm driving my semi-autonomous car. Well, not really semi-autonomous. It will correct itself in the lane.
Oh.
It has adaptive cruise control, and it has blind spot indicators, and all those things I now rely on. I never even considered relying on those things before, and now I've become a poorer driver because I don't even look over my shoulder anymore. So these things have to work, right? Or it'll affect me. So I appreciate the work that you and your colleagues do to make electronics more reliable, and I wish you a huge amount of success as you continue forward and make the electronics world more reliable. Thanks for being here today.
Thanks, Mike, for having me in this. It's been a great conversation with you.
Yes, I agree. And it's been great talking to you. Thanks for listening or watching the Reliability Matters podcast. Be sure to subscribe to the podcast on your favorite podcast app, such as Apple Podcasts, Google Podcasts, Spotify, and so many more. Also, be sure to check out my other podcasts, including the Concept to Creation podcast, where I feature conversations with entrepreneurs within the electronic assembly space, and the Innovations in Technology podcast, where we discuss innovative products within our industry. All 3 shows are also available in video format. Check out the Reliability Matters or Concept to Creation or Innovations in Technology podcasts on YouTube. Just search the show's name and you can find all 3 shows. Or go to MikeKonrad.com. That's Konrad with a K. All 3 shows also appear there. Again, thanks for being part of my podcast family. I appreciate you being here. Until next time, stay safe, stay healthy, and stay happy. And of course, keep doing it right. See you again soon.
Thanks for listening to the Reliability Matters podcast. Join us on the 2nd and 4th Tuesday of each month for new episodes of Reliability Matters.